Hello all. In this video, we are going to see different input devices used in graphic systems. There are various devices available for data input on graphics workstations, and most systems have a keyboard and one or more additional devices specially designed for interactive input. These include a mouse, trackball, spaceball, joysticks, digitizers, dials, and button boxes, and also some other devices used for special some particular applications like data gloves, touch panels, image scanners, and voice systems. Okay, so we're going to see these input devices in detail. Okay, so the first one is one second. So the first one is keyboard. Okay, so keyboard, uh, an alphanumeric keyboard on graphic system is used primarily as a device for entering text strings such as picture labels. The keyboard is an efficient device for inputting such non-graphic data uh, like picture labels, as I said. And the keyboards can also be used to facilitate entry for screen coordinates, menu selections, or graphics functions. Um, the cursor control keys and function keys are common features on general purpose keyboards, and these uh, allows users to enter frequently used operations in a single keystroke, and also to select displayed objects or coordinate positions by positioning the screen cursor. So there are other type of cursor positioning devices like trackball or joysticks, um, um, which may be sometimes included on the keyboard itself. Okay, uh, that's how about the keyboard. So basically keyboard can be used as a graphic input device also. Then mouse. Mouse, everybody know it's a small handheld box used to position the screen cursor. Here we have an image of a mouse. It is used for making relative change in position of the screen cursor. There are wheels or rollers on the bottom of the mouse that can be used to record the amount and direction of movement. The, there are also mouse with optical sensors. Um, there are many types of mouses. There's rollers. Some mouses has rollers, some has optical sensors, like that. Okay, I think you know more about mouses. Then trackball and spaceball. Trackball is a ball that can be rotated with fingers or palm of the hand to produce screen cursor movements. You must have seen, or even on a mouse. You must have seen here. You have a trackball. So this ball which can be rolled. There is another image for trackball. This ball can be rotated with fingers or palm of the hand to produce the screen cursor movement. There is a potentiometer attached to the ball. This potentiometer will measure the amount and direction of the rotation, and with that the cursor moves. Okay. Trackballs are often mounted on keyboards or other devices such as the mouse. Okay. Then spaceball. Um, mm, Spaceball provides a 6 degrees of freedom. That is, unlike the trackball, a spaceball does not actually move. Okay, this is a picture of the spaceball. Here, the strain gauges measure the amount of pressure applied to the space ball to provide input for spatial positioning and orientation as the ball is pushed or pulled in various directions. That is, when it is based on the pressure that you give on this space ball that the movement of the cursor is determined. That's it. So for that they use strain gauges to measure the amount of pressure applied. Okay. They are used for three-dimensional positioning and selection operations in virtual reality systems, modeling, animation, CAD, and many other applications. Okay, it is trackball and spaceball. Then you have joysticks. Joysticks you must have seen. So in some keyboards, the joysticks are attached to the keyboard itself, so that this joysticks will help in the cursor movement. Here is an example of a joystick. It consists of a small vertical lever, this lever mounted on a base that is used to steer the screen cursor around. Most joysticks select screen position with actual stick movement. Others respond to the pressure on the stick. Mostly, this stick moves. There are some joysticks in which the amount of movement is determined using the pressure applied on that stick instead of the stick movement. Okay, so mostly potentiometers mounted at the base of the joystick. That is what is going to measure the amount of movement, and the springs are attached on the base so that the springs returns the stick back to the center position when it is released. So that's how a joystick works. I think you must have seen joysticks also. These were very common input device. Okay. Then another type of input device is a data glove. A data glove is similar to a looks similar to a glove, hand glove, um, and this glove can be used to grasp a virtual object. Okay, this glove is constructed with a series of sensors that detect hand and finger motions, and electromagnetic coupling between transmitting antennas and receiving antennas is used to provide information about the position and orientation of the hand. And using this you can actually grasp a virtual object on a 3D display of the image, or even inside in a screen. So input from the glove can be used to position or manipulate objects in a virtual scene. Okay, a two-dimensional projection of the scene can be viewed on a video monitor, in which you can use the data glove to move the positions or manipulate objects, or like to add objects or remove objects from the view, or a three-dimensional projections can be viewed with some VR, like that. Okay, so that is data glove. I think you got the idea. Next input device we're going to see is digitizers. Digitizers are a common device for drawing, painting, or interactively selecting coordinate positions on an object. These devices can be used to input coordinate values in either a two-dimensional or a three-dimensional space. Okay, so basically these devices is used to scan over a drawing or object and to input a set of discrete coordinate positions which can be joined with straight line segments to approximate the curve or surface shapes. When you see this example, you will understand. This is one type of digitizer called graphic tablets, also referred to as a data tablet, and this is used to input two-dimensional coordinates by activating a hand cursor, either a hand cursor or a stylus like this, a pencil shaped device called stylus. Okay, so this stylus or even a hand cursor can be used to activate uh, uh, a position um, or a particular coordinate. Okay, and this can be used to draw a picture, or you can paint, etc., using this graphic device or a digitizer. Okay, this is an example of a digitizer. Okay, next one is image scanners. Image scanners, uh, here are some examples of image scanners. I think you you have seen scanners. Okay, like handheld scanners, like barcode scanners, or like flatbed scanners, are some types of image scanners. Drawings, graphs, color and black and white photos or text can be stored for computer processing with an image scanner by passing an optical scanning mechanism over the information to be stored. Okay. The gradations of grayscale or color are then recorded and stored in an array, and once we have the internal representation of a picture, we can apply transformations to rotate, scale or crop the picture to a particular screen area. So we can also apply various image processing method to modify the array representation of the picture also. Okay, so that's how the image scanners work. There are different types of image scanners. These are just two types, like a flatbed scanner or a barcode scanner, like this, a handheld uh, barcode scanner. Okay, these are also input devices. The images that are scanned, drawings or graphs or photos that are scanned using this image scanners can be used uh, uh, for graphic designing. Okay. Touch panels. Touch panels allow displayed objects or screen positions to be selected with the touch of a finger. You know what is the touch panel. The touch input can be recorded using optical or electrical or acoustical methods. Okay, the optical touch panel employs a line of infrared light emitting diodes or LEDs um, along one vertical edge and also along one horizontal edge of the frame, and the opposite of this frames, opposite to this LEDs, there will be light detectors, that is on the other edge of the horizontal and vertical sides, vertical edges. They have light detectors, and these detectors are used to record which beams are interrupted when panel is touched. Okay. Then in electrical touch panels, it is constructed with two transparent plates separated by a small distance. One of the plate is coated with a conducting material and the other plate is coated with a resistive material, and when the outer plate is touched, it is forced into contact with the inner plate, and that's how it works. Okay, and in acoustical touch panels, high frequency sound waves are generated in the horizontal and vertical directions across a glass plate, and the touching the screen causes the part of each wave to be reflected from the finger to the emitters, and the screen position at the point of contact is calculated from a measurement of time interval between the transmission of each wave and its reflection to the emitters. Okay, so that's how touch panels work. Then next kind of graphic input device is light pens. Light pens are pencil shaped devices. Here's an example of light pens. They are pencil shaped devices used to select screen positions by detecting the light coming from points on the CRT screen. Okay, they are sensitive to the short burst of light emitted from the CRT's phosphor coated screen. At the instant the electron beam strikes a particular point. Okay, an activated light pen pointed at a spot on the screen as the electron beam lights up that spot generates an electrical pulse that causes the coordinate position of the electron beam to be recorded. Okay. As with cursor positioning devices, recorded light pen coordinates can be used to position an object or to select a processing option, etc. Okay, that is about light pens. Then, uh, next type of input devices, voice systems. That is, there are some uh, systems, graphics works systems in which speech recognizers are used as input device to accept voice commands. Okay, voice system inputs can be used to initiate graphics operations or to enter any kind of data. These systems operate by matching an input against a predefined dictionary of words and phrases. A dictionary is set up for a particular operator by having the operator speak the command words to be used into the system, and each word is spoke several or each word is said several times, and the system analyzes the word and it establishes a frequency pattern for that word in the dictionary along with the corresponding function to be performed. Later, when a voice command is given, the system searches the dictionary for that particular command, like the frequency pattern match, and that command will be applied. Okay, voice input is typically spoken into a microphone mounted on a headset. Here's an example of a voice system. Okay, that's all about some of the graphic input devices.